Assalamualaikum and hi, I'm Nurul Nabila binti Muhammad Razali and I will now present on minor topic earthwork, cost and estimation and water reticulation. These are the contents for the presentation. For the site inventory, we have obtained the information on site such as location and topography for the purpose of the project site inventory. The highest reduced level is 47.453 meter, lowest reduced level is 23.119 meter, and almost 90% of this area is covered by oil palm. The land already has existing road and drainage system, has a flowing river which called Sungai Pulai and consists of few of lowland areas. For site analysis, the palm oil plantation will all be cut down for development. Drainage will be designed based on the gravity flow. The pond will be designed at the second lowest level after the fecal plant. There will be areas of green space in development areas. The land will be varied in platform level and the reduced level at the area for the water tank is lowered because the elevated water tank will be constructed. Scope of work for earthwork are determination of proposed platform level, cut and fill process by using grid method within the site boundary, cross-section of the site plan after the cut and fill works, slope stability analysis by using Bishop simplified method of slice, typical temporary earth drain, soil loss, sediment yield, and sediment basin design for surface runoff. Cut and fill is essential to cut cost and duration of the project. Grid method is used for cut and fill volume. First, 30 meter times 30 meter grid size drawn on topography map. The area of each grid and reduced level of each corner determined. Insert all obtained value in Microsoft Excel. Average of reduced level of all corners for each grid is calculated, the height difference obtained, and lastly the volume of area determined. The negative value of volume indicates the cutting area while positive value indicates the filling area. All the cut and fill volume obtained can be viewed in the report. The cross-sectional view is used to illustrate cut and fill pattern, and our project will have x1, x1, y1, y1, and y2, y2. Slope stability is crucial in every construction project to ensure safety of the project area by preventing the failure of slopes. Bishop simplified method is used. First, we assume the radius of circular failure slope drawn using AutoCAD. The failure slope sliced into 10 slices. A straight line drawn from center of curve until point of action of W. All the soil parameter from borehole assembled into spreadsheet in Microsoft Excel to obtain the value of factor of safety. The initial value of Fs assumed and the step of a successive iteration is repeated until a constant value is obtained. The final Fs must be greater than 1.3. The main objective of water reticulation system is to supply treated water at sufficient pressures and enough for consumers. The others objective can be viewed in the slide. Water demand for each node is computed by referring to Suruhanjaya Perkhidmatan Air Negara. The water demand is determined based on 1 day storage and it is based on the type of premises. The premises and water demand by each premise is shown in the table. The average water demand in pipes approaching each tank is determined based on the total storage volume in the tank per day. To obtain peak flow rate, the average flow rate is multiplied by the peak flow factor depend on the type of area. In this project, the area is urban and rural, therefore the factor is 2.5. Peak flow rate that we obtain is 75.7125 liter per second. Firefighting flow is important for emergency response to ensure that the total capacity of system is enough in response to a fire. In this development project, the housing scheme is categorized as Class C risk, where the maximum number of fire hydrants used simultaneously is only 1 at 1370 liter per minute. Therefore, node 54 is chosen to add the hydrant flow as it is the farthest from the supply node. The flow rate obtained is 53.119 liter per second. According to SPAN, for landed residential premises, the residual pressure at any water fixture shall not be less than 2 meter head and any section of the plumbing system shall not be subjected to a pressure of more than 30 meter head. Otherwise, a reducing valve shall be used to lower water pressure. For multi-story building, the minimum pressure supplied depends on the location. The location and minimum pressure are shown in the table. Flow balancing iteration will use Hardy-Cross method, where it is an iterative procedure for pipe network analysis. The continuity equation is inflow equals to outflow. The head loss is still considered, but only the minor loss, which are the flow through valves and the fittings. The calculation of head loss in this project is calculated based on Darcy-Weisbach equation as in the slide. The height of the elevated supply water tank is determined using Bernoulli's equation after the pressure head at the first node or supply node is obtained. The equation is as shown in the slide. The capacity of elevated tank can be determined from the total average water demand for the housing per day. Flow balancing calculation is done using software called IPANET, which is widely used to model water distribution systems. The water tank is designed. The diameter is 25 meter, workable height is 6 meter, bottom water level and freeboard at top side is 0.3 meter, the capacity is 2945 meter cube, the top water level is 63.6 meter, and all the details calculation can be viewed in the report. Cost and estimation is the technique for predicting the quantity, cost and price of resource required by project scope. The budget estimate is used as a benchmark to analyze the project performance in later phases of the project. For the phase planning, we split the area for cut and fill procedures into two phases in this project. Phase 1 is Z1 until Z5, where it's also called as zone green space. The total area for phase 1 is 160831.881 meters squared. Phase 2 consists of Z6 until Z26, and the area is 265410.443 meters squared. The Gantt chart above depicts earthwork schedules in order of phases. It is used to change task connections, manage task periods, update progress, insert milestones, allocate resources, and produce cost reports. For cost of machinery and operating, there will be 6 machines used in this project: excavator, bulldozer, dump truck, motor grader, wheel loader, and soil compactor. The cost for an excavator per day is 1212.52 ringgit. The bulldozer is 930.45, and the others can be viewed in the table. Lastly, for costing and estimation, the total cost for the project are 2,379,713 ringgit and 43 cents. The table shows the cost before and after reduction. The difference of the cost are 20.02%. With that, I end my presentation for the minor part. Thank you very much for watching.